Project Hail Mary hits the big screen this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. What would you do if you woke up alone in space with no memory of who you are or how you got there, but somehow the fate of every living thing on Earth depends on you figuring it out? That's the premise at the heart of Project Hail Mary, author Andy Weir's latest science fiction epic, now a major motion picture starring Ryan Gosling. Mat Kaplan, our senior communications advisor, and I will share our very first reactions to the film straight out of the theater. Then we'll travel back in time to hear Andy Weir, the author of The Martian, Artemis, and Project Hail Mary, and the producer of this film, as he tells us in his own words what the story is really about in an earlier conversation with Matt. After that, award-winning nature correspondent Alex Witze takes a critical eye to the science in the film. Astrophysicist and Professor Nahum Arav from Virginia Tech's Department of Physics walks us through something life on Earth will have to face someday: the actual death of our star. And finally, we'll close with What's Up with Bruce Betts, our chief scientist. A quick note before we dive all the way in: this episode contains spoilers. We won't be giving away how this movie ends, but we are going to be discussing details about the story and the science behind specific scenes. So if you haven't seen this film yet and want to go in completely fresh, you may want to save this episode for after you've visited the theater. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. For those of us at the Planetary Society, this movie has been a long time coming. Andy Weir's Project Hail Mary has been a favorite among our team since the book came out in 2021. And when the film was announced with Ryan Gosling attached, we've been counting down the days ever since. On March 4th, 2026, that wait finally came to an end. The California Science Center in Los Angeles hosted a special early screening for space educators, scientists, and journalists. That included researchers at NASA and JPL, observatory workers, members of the astronomical societies, a lot of social media content creators, and many of the others in the broader Los Angeles space community. Meanwhile, on the other side of the country, our space policy team attended a screening at the Smithsonian National Air and Space Museum in Washington, D.C., alongside NASA's new administrator, Jared Isaacman, and many others in the D.C. space community. We want to send a huge thank you to California Science Center and the Air and Space Museum, along with all the sponsors who made these special screenings possible and were kind enough to invite us. Getting to see this film on a giant IMAX screen while surrounded by people who love space as much as we do was something really special. Or as the film's characters might say, amaze, amaze, amaze. I attended the screening with a few members of the Planetary Society team, including Mat Kaplan, the creator and former host of Planetary Radio and the Planetary Society's senior communications advisor. We caught up right after the credits rolled. Well, Matt and I are here at the California Science Center. We have just seen an early screening of Project Hail Mary, far earlier than I anticipated. How are you feeling about it, Matt? I know you are such a big fan of Andy Weir.
Oh my God, oh my God, oh my God, oh my God. This is for Andy. Andy, it is, I can't use the word I want to use because this is going to be on the podcast. It is so blanking great. They really did you proud, buddy. And we loved it. And I got the impression that everybody here at the California Science Center felt the same.
Well, Andy's books are so wonderful to read, but they lend themselves so well to the big screen. Watching The Martian was one thing, but this was a story that I loved the moment I read through it. I was so passionate about it. Watching it get adapted to the big screen was really interesting. What would you say for you are the biggest differences between the experience of reading it and actually getting to watch it?
You know, I think they found just the right balance. They couldn't include everything in the book, so they did a terrific job distilling it into still a 2.5-hour movie, roughly. But the visualizations, the stuff that they brought to life that you could only really imagine, even though Andy did a terrific job describing them in the book, like the ship. And I think they evolved the ship considerably beyond, sorry, Andy, what you conceived of, and I hope you're very proud of it as a producer of the movie. But just, you know, Rocky was extremely well executed, I thought, and really, rather than what was different from the book, it's so much of it being true to the book that they were able to retain. And even the ending, which I won't give away, which they expand and make just spectacular, I thought, the theme of friendship and where courage really comes from, I thought were just beautifully executed and expressed in the film.
I agree. You find someone to do it for. I think they made a beautiful point there. And I'm just so glad I got to see this. I'm so glad I got to see it with you. And I'm so excited for everybody out there that's about to get the experience of watching this movie. If you have any last thoughts for people who might be on the fence about going to see this movie, what would you say?
Listen, I will tell them, as I've mentioned to you, one of my daughters who's read the book, not a big science fiction reader, but enjoys it, grew up on Star Trek. She was in tears at the end of the book. I cannot wait. I want to see the movie with her and my grandson. I expect it to be a wonderful experience. And just two more words, man. Ad Astra.
Ad Astra, Matt. Thanks for coming out here and being with me and everyone else tonight to see this movie.
What a pleasure.
In case you're wondering, Mat Kaplan did, in fact, get to take his grandson to see Project Hail Mary. And I really hope it was every bit as magical as he imagined. Mat Kaplan has had the pleasure of speaking to Andy Weir many times over the years, and those conversations have always been some of our most beloved episodes. Andy, if you're listening, I want to thank you. Thank you for the worlds that you've built, and for the science that you've championed, and for making time for Planetary Radio over the years. We had hoped to bring Andy on for this very special episode, but as you might imagine, when a movie takes the world by storm the way that Project Hail Mary has, the author's schedule kind of fills up fast. So instead, we're going to go back in time a few years to one of Matt's earlier conversations with Andy. We're about to relive the moment that Andy first shared the exciting news with Matt that Project Hail Mary was going to become a movie. He was so enthusiastic about the team coming together to bring it to life. Here's Mat Kaplan and Andy Weir back on May 5th, 2021.
There may just be some spoilers in the coming minutes. So why don't you start by saying, what are you comfortable saying about the story that is Project Hail Mary?
Well, in a pre-spoilery way, the story starts with a man waking up with complete amnesia. And so literally anything in the book that I tell you about is kind of a spoiler. But you very quickly find out, through some experimentation, he realizes he's aboard a spaceship. And as his memories start coming back to him, he realizes that he's on a last-ditch effort mission to save humanity from an extinction-level event. So, no pressure.
It's a Hail Mary pass.
It is a Hail Mary, yep. Basically, the premise of the story is that an alien, a genuinely extraterrestrial microbe, enters our solar system. And these microbes are, they're not intelligent. They're just like the size of bacteria, whatever. And they grow on the surface of stars in the same way that algae grows in the ocean. They collect energy. They migrate to nearby planets to breed. And because the star itself will only have hydrogen, so it needs other atoms, other elements to be able to reproduce. Then it comes back to the star and the life cycle begins anew. When it's on a star, it's also sporing out. It's making God knows how many of these, like 10 to the 20th of them, whatever. And it's sporing out in all directions to seed other stars. It's just like mold or algae or anything else. Problem is, it's breeding so out of control on the sun that the solar luminance is going down. Oh, by the way, they're called astrophage. It's what the scientists of Earth call it. It's Greek for eater of stars, which is a bit dramatic. It's not eating the sun any more than algae is eating the ocean, but it lives there and it's causing us a problem.
Eating a lot of photons. That's what
it's eating a lot of photons, yeah. So our hero was given, there was a space mission to collect a sample of this stuff and everything, and our hero is able to get a hold of 3 astrophage cells, just 3. To experiment with, and then basically figures out how to make them breed. He figures out the process to artificially make astrophage reproduce.
Have you heard from anyone who wants to turn Project Hail Mary into a movie? Because I'd be first in line.
Yes, it's plugging along. MGM bought the film rights, and then we also have Ryan Gosling attached to play the lead.
Oh, wow.
Which is awesome because he has the same initials as Ryland Grace. So he could bring his own cufflinks to set.
That is a terrific choice. I think he's great for that part.
There's something uniquely powerful about the way that movies and television can bring science to life. For generations, stories told on the screen have sparked curiosity and sent people down paths that they never expected. From the scientists who cite Carl Sagan's Cosmos as the moment that everything clicked, to the engineers who grew up watching Star Trek and decided that they wanted to build that future. Science fiction has always been one of the space community's greatest recruiting tools. Project Hail Mary is one of the latest chapters in that tradition, and if the conversations already happening around this film are any indication, there's a whole new generation of future scientists, engineers, and explorers who are already about to fall in love with space because of this film. Alexandra Witze, who goes by Alex, is an award-winning science journalist and correspondent for the journal Nature, based out of Boulder, Colorado. Among the many topics that she covers, she loves exploring the way that science shows up in our culture and stories, and Project Hail Mary gave her plenty to work with. Just a few days before the film's wide release on March 20th, she wrote a piece for Nature titled, "Project Hail Mary Film Builds Dazzling New Worlds and Grounds Them in Science." Alex also attended an advanced screening of this movie and spoke with some of the film's scientific advisors to examine just how well the filmmakers brought Andy Weir's science-steeped story to life. Hey, Alex, thanks for joining me.
Hey, thanks for having me.
You know, anytime there's a big science fiction book that I'm very passionate about, I always get really antsy going into the movie theater to see it projected up on a big screen. I'm always worried that they're going to diminish the science or get it wrong in some way that makes the story feel less impactful for me. So what was your first impression kind of coming out of the theater from Project Hail Mary?
You know, I actually liked the movie quite a bit more than the book. I'm probably going to get some outrage for saying that. I wasn't a huge fan of the book, to be honest. It was just, the book to me was kind of a lot. So going into the theater, I thought, okay, this is going to be a bit overwhelming. There's going to be sure, there's going to be science, people are supposed to like science, but it's going to overwhelm me and I'm not going to be into it. But honestly, I think the screenwriter and the directors did a great job of simplifying and streamlining stuff down. So to me, the movie was like, hey, this is world building. This is visuals. These are things that are bringing stuff to life that to me weren't totally popping in the book. So I came out of the movie theater pleasantly surprised.
I had the same feeling. I wouldn't necessarily say I liked one over the other, but I think because of the visual elements of it, it was very impactful. And I loved that they used a lot of practical effects to try to get this across. So often when you have space movies, it's a lot of CGI. So the way that they constructed this just felt so grounded and made the science just feel so much more real, I guess.
Yeah, it just seemed like, when you're reading words on a page, there's only so much you can kind of imagine what's going on. But to me, again, just the visualizations really kind of brought this world to life that I hadn't just clicked through in the book itself. So yeah, I thought it was really enjoyable.
Yeah, myself and some of my other colleagues here in the LA area got to go see it at the California Science Center. And then we had another contingent go to see it at the Air and Space Museum in Washington, D.C. So for anyone who's listening to this, I just want to call out there are a lot of big IMAX screens at some of your local science museums and institutions. So that's a good way to go see it up on a big screen if you want to and support your local science communicators. 'Cause, man, did you see it in IMAX?
I did. It wasn't IMAX theater. It was just a chain. It wasn't like a science center anywhere, but it was an IMAX and it was super immersive and beautiful. And it was funny because I was there with the movie critics. So you could hear people talking about science who weren't into the science part of it. They were just there. They just reviewed every movie that came out or whatever. So it was kind of a fun ambiance. It was not the science geeky scene that you probably had a little bit more of.
Yeah, our audience was full of basically a bunch of local scientists, people from JPL and other institutions, but also, science influencers online. I saw some people that I recognized from TikTok. So it was a very interesting crowd to be there. I will say as a warning for some people seeing it on IMAX, because it's a space movie with so much of that kind of zero G and kind of spinning motion, it did feel a little jarring. I did kind of almost feel like I was staring out the cupola in the space station, just very, very visceral feeling watching it on a big screen. Was it the same for you?
Yeah, very motion oriented. And I don't usually do very well with like motion things, but funnily enough, it didn't trigger me on that. And one thing I have read later in interviews with Ryan Gosling, who of course plays the main character here, is how he studied Charlie Chaplin to sort of get at this clumsy but intricately choreographed movement in space. So a lot of his kind of grappling with zero G, trying to kind of get around the spacecraft initially on. If you go back and look at some of these Charlie Chaplin movies, and I'll have to look up the name of exactly what some of the ones he was studying. It's the one where Chaplin goes through the gears of a clock in a very fluid and weird manner. You can sort of see how that translates to the motion. So when I was looking at this motion on the big screen, I noticed it mostly with the spaceships when the spaceships were doing things, but also when Gosling was kind of doing this very not choreographed. It's really more fluid acting, fluid movement. And if you go and look at Chaplin, you're like, that's it. It's like Chaplin in space. That's one thing that struck me, the human body movement in space.
You call out too, because a lot of that is in the beginning of the movie, and you call it out in your Nature article that the beginning of the movie is just like really well constructed, with him kind of waking up from his, cryo sleep and entering this amnesia phase where he doesn't know what's going on. And I think too that this kind of opening, the comedy of the way that he plays this character, juxtaposed with the sadness, just really gives this movie such an emotional depth that I don't necessarily get out of a lot of science fiction films.
I love the start to both the book and the movie. The fact that and I just love kind of very straightforward mysteries, but you wake up, you're on a spaceship, there's dead people next to you, you don't know who you are. It's very simple, but starting to unfold that is just, I think, a really good plot device and a really good way to draw people into it. So for both the movie and the book, actually, I thought, the opening was like super strong. We weren't just kind of somewhere trying to world build and like get all the details and what's happening right away. It's just like, hey, here's one thing to pay attention to, and our story will open from here.
They even did it early on when they were trying to explain the basic premise of astrophage. Instead of, getting really deep into the science immediately, they set up this scene where Grace's character is doing what he did for his job. He's a science teacher, and he's trying to explain it to the kids. And you've spent a lot of time writing about the science of filmmaking. How do you feel like this movie did in actually communicating the science to a general audience?
Well, clearly the movie simplified stuff down a lot, right? So I think a lot of that, again, with the screenwriter and the directors in fact, the directors are from an animation background. They're used to telling just very visual stories without a whole lot of technical detail in them. So, I think the movie did a great job of stripping away a lot of that technical detail that might have just, completely bogged folks down when they were reading it. And having, Gosling's character, having the Grace character kind of do the teaching moment at the beginning, felt like you were just getting through the stuff you maybe needed to know. But it was really notable. He didn't go on to some giant lecture with his kids about like what astrophage was. You kind of had to sort of know. And I found myself wondering a lot of times when I was watching the movie, like if I hadn't read the book, would I know what's going on?
Yeah, I wondered that too. And I would have to ask someone who's just going into this without any context from the book, because I felt like there's a lot of science backing to the way that astrophage is written within the story. There's a lot of explanation of the chemistry. There's this mass energy storage going on, a CO2 breeding cycle, even this kind of radiation blocking membrane. And a lot of that is communicated visually rather than through actual explanation of the science. How much of that do you feel like you actually got from watching it, or was it because you were interpreting what you already knew from reading it?
I think I got a lot of stuff visually, to be honest. When you see this astrophage stuff, you see it looks like, stuff you would see under the Petri dish or whatever, this like oozy black stuff. And just seeing it kind of makes you think, oh yeah, that's like biology, instead of, just seeing it in black and white. And also I read the book on Kindle, which is never very helpful for visualizing stuff because you're like clicking pages every like 2 paragraphs. So that probably didn't help. But yeah, to me, the visuals, just seeing the astrophage, seeing that Petrova line, right? This incandescent line, right? Going from the sun across to Venus was very, very reminiscent, right, of other science fiction movies too. It glows like, the sabers in Star Wars and stuff like that. It just had more of a resonance for me to see it visually. And I think if you haven't read the book and you go into the movie, you'll be able to follow, maybe not understand everything that's happening. But I think you'll be able to follow the plot just fine. Like, don't get hung up on like what exactly is happening with neutrinos in the astrophage, and like, because you don't really need to know that to enjoy the movie, but go with it if you can.
The astrophage too are a great example of kind of the difficulty in trying to discern what life is and is not. Like, you meet a creature like Rocky, and sure, made of rocks, but clearly this creature is alive. It's communicating. It has a whole life cycle. They breed, that kind of thing. But astrophage, it really kind of drills down to this issue that I think we're going to really have a lot of problems with going forward in the future. Say we find some bacteria inside of Enceladus or something. How well do you think the film kind of captured that complex question when it came to astrophage?
I think both the book and the movie did a great job with that in astrophage, because when I was reading that, when I was seeing it in the movie, it made me think very much of all the times I've reported on, oh, look, there's a hint of phosphine in the atmosphere of Venus, and is that a biosignature gas or not? Or, oh my gosh, is there dimethyl sulfide in K2-18b, an exoplanet that might also be a biosignature? Now, astrophage is not, a molecule in a gaseous atmosphere, but it's the kind of thing. I mean, I covered Alan Hill's 84001 when people were arguing about, is this squiggle in a rock, a fossil of a life form? And you sort of look at the astrophage and, until you see it, reproduce and spread or whatever, then it's obviously living. But what is it, right? What does it say? What does it say about what life is and how weird and unique it might be, and how similar to just microbes on Earth it might be as well too. So one of the things I really love about Project Hail Mary, and I have a lot of critiques as well too, but the things I love is these two different alien species, right? You've got astrophage, which is like slimy algae stuff, non-sentient, but doing its own thing to evolve and survive in the universe. And then you've got the sentient creature, Rocky, which I guess we're not doing too many spoilers, but there is an alien creature named Rocky, and he is sentient. So.
Yeah, I really did think whether, when I saw the trailer for the movie, I actually had some coworkers that are like, I don't want to see the trailer. I don't want to see what Rocky looks like going into it. But they kind of gave that away right out the gate. And I wonder how that impacted people's experience of the movie as well.
Yeah, but he's so super cute. You just want to snuggle him. Yeah.
But in their case, they have the kind of privilege of having samples of this astrophage in order to work with. When we're seeing things like, dimethyl sulfide and K2-18b, all we have is some spectra to go off of. So it's really difficult to make that interpretation. And one of those reasons why it's so important that we try to bring back samples from other worlds. When we see things like the chemical signatures inside of the, resultant rocks from asteroid Bennu, like that just absolutely blew open the lid on so many things. And I'm wondering what you think about the efforts to kind of bring samples back from places like Mars, or say get samples from the atmosphere of Venus for something like the phosphine detection.
Yeah, exactly. And I have to say, sampling Venus's atmosphere for phosphine was exactly what I thought of. There's this scene in the movie, again, not spoiling too much, but there was, a gaseous planet and they're trying to sample from it for various reasons. And it's a very visually dramatic scene and lots of things happen. But fundamentally, they're trying to scoop stuff out of this gaseous atmosphere to bring it back for study, at least in their spaceship, if not necessarily to Earth. And I just kept thinking, boy, if we could just fly through Venus and scoop that up and bring it back, which, some folks are talking about doing in different types of missions, it would be incredible. I mean, the importance of sample return, you've covered it a lot, on Planetary Radio and other publications. We know a lot about how important it is to get physical samples back so that we can study them with modern techniques and figure out what they are. And that's very much a theme in Project Hail Mary. We got to go out, we've got to find what this stuff is, bring it back, test it, and then we can figure out where to go from here. And it feels like when it comes to alien life, to what we might expect from extraterrestrial life detection, that's going to be a real key portion to it. So we had all the equipment to go flying into the atmospheres of these planets and scooping stuff up. That'd be great. Let's do it. Let's do it tomorrow.
Yeah, I loved watching that because it was literally last year in September. I was at NASA's Innovative Advanced Concept Symposium, and someone actually dropped a proposal that was almost the exact same technology as was used in that scene in Hail Mary. So people are working on it, and I hope it works out because, I mean, clearly a place like Venus is something that we need to study a lot more. But you can go to other worlds and do this kind of science. There's also the science of what we send out to other star systems. And the classic example is this Voyager golden disk. And as I was watching this movie, there's literally a scene where Grace is trying to interpret what is essentially Hail Mary's version of the golden disk up on the wall. And then you get this kind of parallel in the way that he is trying to explain to Rocky where they both come from with the Xenonite sculptures. How closely did they represent the modern day kind of conception of how we can explain messages to extraterrestrials, particularly like location data?
Yeah, I think that's really interesting, especially when the characters are sort of building like little tiny models to kind of explain in three-dimensional space, like how, our star relates to their star and like where we fit in the map of the world. That's funny because I thought I saw that in the movie, but I wasn't sure. I thought I saw like the pulsar map from the Voyager record. Okay, I did see that. I wasn't imagining things. And yeah, the modeling of kind of how do we represent ourselves in space and like what information would an alien need to identify like where we are. One of the things I thought really liked about the whole Project Hail Mary project is this notion of kind of our solar neighborhood, right? So that we're not just Earth and the sun and the planets, we're not just this solar system, but it really expanded to kind of think about, hey, what are our other stars just kind of around us? And what are the planets around those just like? So we're not talking about, traveling all the way across the galaxy or, whatever. We're just talking about our solar neighborhood. And so then when you meet the alien, how do you represent that? How do you sort of convey that information where we are? And I thought that those three-dimensional models that they did in the film seemed to handle that really well. Like I would know, I mean, I'm not a scientist, but I know enough about, the solar system that if an alien handed me that, I could sort of figure it out, and they were able to do that in the film.
I love too the planetary systems that they chose, right? And you note this in your article that the choice of using Tau Ceti is probably very strategic on Andy Weir's part, not just because of its location, but because of its role within the search for extraterrestrial life. Can you talk a little bit about that?
Yeah. So the choice of Tau Ceti is really interesting, of course, because it was the subject of essentially the first modern SETI search. Frank Drake in 1960 pointed a giant radio telescope at Tau Ceti to listen for signals from extraterrestrial intelligence if they were there. So it has many, many resonances through, all of kind of SETI history. And then the other planetary system that they talk about as well is also super interesting. So 40 Eridani is a star that in the Star Trek universe has a planet, Vulcan, around it, where Spock comes from. So there's like all that sci-fi resonance as well, too. But in terms of modern astronomy and modern exoplanet science is also super cool because there was, at the time Weir wrote the book, a planet believed to be in orbit around the star 40 Eridani. It has since been shown to probably have just been an artifact of, the activity of the star itself and not actually a planet. But I love that he chose these places, right? Tau Ceti, the original SETI search from Frank Drake, and then 40 Eridani, which is both, Star Trek Vulcan mythology, and also a place where a planet was thought to have existed.
And even if that planet doesn't exist as we know it now, using the existing data, Andy Weir kind of tried to piece together what some creature might be like living in that system, which is how we kind of arrive at Rocky. How often is it that you see a film try to take the science and actually extrapolate out what might be there versus just kind of making it up?
Yeah, I mean, I've hardly ever seen anything like this. So I trained as a geologist before I went into science journalism. And one of the things that was really striking to me about this film is how like the geology and the mineralogy of Rocky and his world and his ship. So Weir kind of built this creature based on what he thought the pressures and temperatures and magnetic fields would be like on this planet based on the parameters that were thought to exist at the time. And so you look at it and it's like a creature from, I mean, he's a rocky world, obviously, but he looks like a rock. His ship looks like a glittering mineral. I just kept looking at it thinking high pressure, high temperature mineralogy, like all the way. And I've never seen anything like that in any other, film. I mean, there are, attempts to talk about, if you're living in the atmosphere, maybe you're a floating ethereal kind of being, but here's a very, high temperature, high pressure kind of dude. But everything about his world reflects that, right? The structures he lives in, the little, clear glass case he has to build around himself, this clear xenonite case he has to build around himself, his big, crazy looking, sparkling crystalline ship, which kind of shouts, hey, like minerals and geology are important to me because I live at really high pressure. I've never seen anything like that.
No, the construction of that ship was absolutely amazing. And I bet somewhere they have a giant actual 3D model version of it, like they did back in the Star Wars days. I can't imagine how else they did all of those scenes.
Yeah, I'd love to see that.
They also, in the film, give kind of a shout out to amateur astronomers that are monitoring stellar brightness, this kind of differential photometry that a lot of people do when they're trying to look for exoplanets passing in front of stars. And you flag it in the article that this is actually a call out to the people that noticed that Betelgeuse, the star in Orion, was dimming over time in 2019. It turned out, clearly it's not astrophage, and it wasn't an imminent supernova. So what ended up being the case with Betelgeuse?
So Betelgeuse just turned out to be that the star was belching a whole bunch of dust, which kind of obscured it and make it look dimmer at certain periods of time. But I did talk to Andy Howell, who's an astronomer at UC Santa Barbara, who was an advisor to Weir on the book, a little bit on the movie, but more on the book. And he told me that he was the one who talked to Weir about kind of this notion of the astronomical community and who is out there looking for, these types of things at any given time, that it's not going to be some professional astronomer staring at a nearby star looking for fluctuations in brightness. That's just not like a big discovery space. But there's this huge network of amateur astronomers, like through the Variable Star Observers organization, who track these things super closely. And they were the ones who first detected that Betelgeuse was dimming. Turns out, fortunately, is an astrophage, but there was some interesting, cool stuff going on, and that was a big science question for a while in 2020. Like, what's happening to Betelgeuse? Why is it dimming? And it turned out to be these dust belches, not astrophage. But those types of stories and that type of community, and like kind of how citizen science and community science plays into our stories in science fiction and our community stories and how we interact, I thought was a good shout out to not just professional astronomers, but really the amateurs who kind of keep the heartbeat going for a lot of this stuff.
You also noted that Andy Howell said something about how many people might be inspired to go into science because it was specifically Ryan Gosling who was portraying Ryland Grace, right? I had a coworker say, I don't know whether or not he's going to be that great in this role. He's too attractive. And that's not the way that we usually depict scientists on the screen. But I think because of his emotional breadth and the way that he plays this character, he just feels so human and so real. How many people do you think might actually be inspired to go into science specifically because of that character?
I think it's probably going to be a lot, right? So anecdotally, we hear that a lot from like The Martian, where Matt Damon, this was Andy Weir's first book, where, Matt Damon in the movie version was stranded on Mars and had to get himself off and grow potatoes in the dirt and all that stuff. And anecdotally, we have just heard a lot from a lot of, especially professional scientists too, who are already in the field, that they were really inspired by that. It made them feel like, they're what they do and this sort of scientific mindset of questioning and problem solving is worthwhile. And then I have to say, I was super skeptical of Ryan Gosling, going into this film. I'm like, how is this going to work? Like,
right.
And like on the spaceship, not going to work. He was great, right? Because he brought a lot of humor. He brought a lot of, just kind of organic humor to the role, which I didn't really know he had as an actor. I think because I had seen him in First Man, where he plays Neil Armstrong, and he's very buttoned up and closed down, and because that's who Armstrong was. And I was actually thinking about going and like watching like those movies back to back just to see how different he was in those two, like Neil Armstrong versus Ryland Grace.
It's funny because what I did was I immediately rewatched the Barbie movie to see that juxtaposition of his acting. But yeah, clearly he has a lot of depth in this role. And I know that, I myself was really inspired by some of the people I saw in science fiction as a young girl. Seeing any depiction of a scientist or a captain as a woman really changed my life. But still, people feel like science is pretty inaccessible. It can be very scary to go into that field. And that's part of why I want them to get the science right and make it so accessible. So I think there might be a whole generation of kids that are seeing this movie growing up thinking Rocky is the most adorable, only to realize they want to be a geologist or they want to go into exoplanet detection or something.
Yeah, and I think that the character of Grace was, he solves problems, but not in like a boring way. He doesn't just sit down and like crank through the math. He's really just engaging with stuff that comes to him. He's engaging with the challenges to overcome. And, we see this in like, other dramas where, I don't know, maybe a sleuth is like solving a mystery in some way. But here we have a scientist doing that problem solving, and he's like a normal, funny, happy-go-lucky kind of guy. And that's like Hal talked about this quite a lot when I was interviewing him. That's just not really a character we see on the screen very often. I mean, there are really stellar, scientific characters. I mean, you think of like, Jodie Foster in Contact, where she plays Ellie Arroway, who's like, she's an amazing character with an incredible backstory and just an incredible actor. You wouldn't call her like approachable. That's not the character, but Gosling's character in this maybe is just a little bit, more approachable in terms of, not being sort of the stereotype of a scientist, somebody who's just there for the joy of curiosity, for the joy of discovery, for the joy of chatting up his new alien buddy.
And even prior to that, the joy of sharing science with young people. I love that they chose someone who not only was into the science, but wasn't necessarily on the path that you think of most people would be on if they end up in this situation, right? I really love the way that they wrote this character. And you close out this piece by kind of noting Andy Weir's optimistic worldview, that even people and aliens can come together to try to kind of solve these giant, impossible problems. And that really feels like the message that we need right now in 2026. And so I wanted to ask you, without going into any politics or anything, why do you think this message resonates with you so much right now, particularly when we're talking about this moment in science?
Science is so much about just trying to figure out what's going on in the world. And right now, there's just like so much chaos and disinformation and confusion and stress and, global uncertainty and disruptions like everywhere. So, having a message like that at this moment, I think is one that's, it brings everybody together, which, I mean, you're saving all of humanity at the end of the day. And I think it's a message we can kind of all get behind right now, right? When everything is so stressful and confusing and disruptive, it's like, yeah, let's just work with somebody to figure this out and get this done.
Right. That's part of why I love space exploration so much. It builds bridges across continents, across nations, across people, so we can just really kind of solve problems together. So I love seeing it represented on the big screen, and I'm so excited for everyone who gets to go out there and watch this movie now. Well, thank you so much, Alex, for joining us to talk about this movie, and good luck with all the rest of your reporting. Working at Nature is not a job for the weak of heart.
Thanks for having me today.
We'll be right back with the rest of our conversation about Project Hail Mary after this short break.
Greetings, Bill Nye here, Chief Ambassador of the Planetary Society. Last year, you showed up, and it made all the difference. Tens of thousands of you sent messages to Congress, you traveled to Washington, you made your voices heard, and together we stopped nearly 50% in cuts to NASA science. That victory, that was you. But the fight isn't over. New challenges are here. Your gift today keeps our advocacy efforts going strong so that next time we can act fast, fight hard, and win again. Together, we're not just saving NASA science, we're protecting humanity's greatest adventure. So please check out planetary.org/takeaction. And together we can carry on, keep exploring, and change the world. Thank you.
Project Hail Mary imagines a fictional scenario in which our sun is being slowly drained of its energy by an alien microorganism. That's not going to happen, as far as we know. But the truth is, our sun will come to its end one day, and so will every other star in the universe. So what does the real death of our sun look like? And what does it mean for the future of life on Earth? Dr. Nahum Arav is a professor of astronomical physics at Virginia Tech's Department of Physics. And he joined us to talk about the life and inevitable death of our sun and what it means for the long-term future of our species. Hey, Nahum, thanks for joining us.
Thank you for having me.
So in Project Hail Mary, the sun's energy is basically being drained by these organisms called astrophage. And this leads to this sudden cooling and a looming ice age here on Earth. But in reality, how stable is our sun's energy production?
Well, let me enlarge the scope a little bit. We need to recognize that in order for us to develop on Earth and basically get to this interview, there was 4.5 billion years of evolution on the planet. The biological evolution is very, very fragile and can be destroyed by bad behaving star. So basically what happened is that by necessity, we have to be around a star that is very stable on this long time scale of more than 4 billion years. And not only that, but it should not have any kind of wild behavior that can endanger us. So I'll give two examples. The more massive stars that live more exotic lives are burning very quickly. And let's say 10 solar masses star will end its life within 10, 20 million years after it was formed with a big supernova. So 10 to 20 million years by our one example is not enough to develop life. It takes much longer to get intelligent life, okay? So obviously, these planets around massive stars are a no-go. They're not going to have biological creatures, especially not intelligent creatures. And the other thing is that smaller mass stars are living even longer than the sun, and they can be very stable in their energy production, except that they have wild episodes of huge flares. They can have episodes for a while that they can produce 100 times more radiation. And if that happens, they fry the entire surface of the planet and sterilize it, and things have to start again. So we are fortunate, or by necessity, the fact that we are here saying that our star was stable for a long, long time, stable for about 10 billion years. So we are about halfway, and so we don't have to lose sleep about anything happened to us because it's 5 billion years away. And then just to give a little bit of description of the exotic stuff that will happen later, when the core of the sun exhausted all of its hydrogen, it becomes made of helium, it collapses further, which make the sun bloat. It will expand to about 100 times its current radius. It will become what we call a red giant. At this stage, it will also be almost 1,000 times more luminous. So as this phase starts, everything on the Earth will be fried for good. We will be baked to crisp. But this is basically our main worry with that. So I sleep easily still. And what we have is that phase is going to be very interesting because after the red giant forms, the outer shells of gas are being expelled. And they are becoming the beautiful object we see in our galaxies called planetary nebulae. They have nothing to do with planets, but in early telescopes, people saw them, they had a disk, and they looked sort of like a planet. So they call them planetary nebula. It's very confusing. It has nothing to do with planets, okay? So that phase will live for a very short time, probably a few tens of thousands of years until the gas will disperse and disappear from view. And the next thing is we are left with a very dense core. Most of the sun's mass will be in the form of a white dwarf, which is almost the mass of the sun, but in the size of the Earth. So it's almost 1 million times denser than what the Earth is now. And then this is how the sun will die ungloriously as a white dwarf that will exhaust all of its internal heat and will become a black dwarf, and that's it.
But there's also another common misconception that I've run into when people think about the sun. They know that some stars go supernova when they die, but a star's fate is determined by its mass, and our sun just simply isn't big enough to do that. So why does the mass set this kind of fusion limit, and why is the sun destined just to be a white dwarf and not something like a neutron star or a black hole?
The sun is massive enough to burn hydrogen and to start burning helium. But it doesn't have enough temperature to burn anything heavier, like carbon and oxygen. So it will end its life quietly. After it burns stuff, it will just become a white dwarf and nothing else will happen, and it will be probably a helium white dwarf, that the core is basically made of helium particles. A heavier star can maintain higher temperature, so we start fusing heavier elements. Think about nuclear physics. There is a very interesting thing in nuclear physics, and that is the amount of energy that different elements or nuclei has. When you have in hydrogen, you have a lot of energy to give while you're fusing helium. This is the core reason why the sun produces so much energy. Every successive stage, you get less and less energy moving from one nucleus to the other, and it all ends in iron. Once you get to iron, there you don't get any more energy. So interestingly enough, timescale, we said that the sun is burning hydrogen for 10 billion years. A massive stars, when it's burning from silicon to iron, it takes less than 2 weeks to make all the mass of the silicon into iron. But iron is the end because you're not going to get more energy. You cannot support the weight of the star with the thermal pressure of the burning material. So you have an iron core that is inert and becoming bigger and bigger. And at some point, it becomes so big that it cannot support itself and has a catastrophic collapse. And very interestingly, the core, iron core, at that stage will be about the size of the Earth, and it will collapse to a neutron star within 1 second.
Can you imagine?
Think about the Earth that you see on all these beautiful pictures from space vanishes to basically, instead of the current 6,000 miles or so, or 12,000 kilometers, collapse to 10 kilometers radius. So that's what happened in 1 second. If the star had a mass anywhere between 8 and 20 solar masses, the end result will be a neutron star, which is 1 billion times denser than a white dwarf. A teaspoon of a neutron star is weighing more than the Everest, the whole mountain Everest. But if it is heavier than that, even that won't support it, and it will collapse directly to a black hole. That's how we know to produce black holes from stars. Stars above about 20 solar masses will end up their life very quickly and as black holes.
I always love the diagrams of the biggest stars with all their different kind of, I think of it almost like a jawbreaker, right? You have all these layers, these fusing layers, then the layers of elements between them. It is so cool what happens with these larger stars, but I'm quite thankful that we live around a smaller star, much more chill than those ones, and definitely less volatile than things like the red dwarfs. But so you mentioned that we basically have about 5 billion years before our sun enters this red giant phase. But even before that, it's, the luminosity of our sun will change a little bit over time as it gets closer to that. So how long do we actually have before that poses a threat to life on Earth?
Normally, I gloss over that, not to overburden the listeners.
I know, here comes some existential crisis.
What happened is we have good models of the sun, and the sun we now see indeed is slowly but surely increasing. As I said, in 5 billion years, it will increase drastically. But what we're going to have is the luminosity of the sun in about 1 billion years will be high enough that we will get an effect like on Venus. We'll have a runaway greenhouse effect on Earth. The heat will be, the temperature will be high enough that we will boil all the oceans. The temperature will drastically increase. The oceans will boil and disappear in space within a short amount of time. And we will be basically a barren wasteland with no life, because the temperature on the Earth will be for a good while, just like the temperature on Venus, which is about 700 Kelvin or 400 Celsius, which is not conducive for life.
But see, that gives us about 1 billion years to become an interplanetary species. Problem solved. That problem is actually quite large. But okay, so we'll put that aside. Let's just imagine we figure that out. But when the sun actually enters this red giant phase, it is going to get much larger. Do we know from modeling whether or not it's actually going to be large enough to swallow the Earth entirely? Or is the Earth just going to become this kind of charred, airless, molten rock?
This is a very popular question. Currently, the good money is on that we are not going to get all the way to the Earth orbit. We're going to cover Mercury, we'll get closer to Venus, but we'll be about only half the distance or a little bit less from the Earth. So the Earth is going to be charred, as you said, but it's not going to have a cataclysmic event where if the envelope of the star is engulfing it, it will just spiral into the center of the star after some time. So no, we're probably not going to be there, but for life, it doesn't really matter. You will be dead anyway. So.
Right. But who knows? Maybe that means give it another several 100 million years and we'll have to initiate our own kind of Project Hail Mary, not necessarily to answer the question of what is astrophage and why is it destroying our sun, but we're actually going to have to work together to get humanity and the other life into a safe place on another world, which begins with so much other science, understanding our climate, understanding exoplanets, understanding our stars. There's a lot we have to do between then and now.
Yeah, definitely. I will just put my 2 cents in. I strongly believe that the evolution we saw on Earth doing so much and so successfully in 4.5 billion years, it's at the exact end of its importance. Biological evolution will continue on the snail pace, but our evolution is now going much faster because we are changing it with our own hands. So basically, we are going to look at very different creatures, very different humans in even 100 years, but definitely in 1,000 years, with very different capabilities. It's like a seed that went through the ground all the way seeking the sun in 4.5 billion years. And now we got to the surface and a huge tree will sprout. And we have no clue what will happen, but it will be very different than what happened in the last 4 billion years.
Yeah. I mean, think about the ways that we would have to adapt, not even to live on another planet, but just to venture through interstellar space to get there. That could produce all kinds of changes in us. And maybe it happens evolutionarily, and maybe it happens because we've kind of jumped the shark. We now have the ability to functionally change our own biology. So, it'll be interesting to see what happens and how human exploration of space over the next few decades impacts that journey.
Exactly. Truer words were never said.
Thank you so much for joining us to explain what's going to happen to our sun. And hopefully we haven't given anyone horrible existential thoughts about the death of our star.
Well, thanks, Sarah. I enjoyed the interview and I wish you the best of luck with this program and any other program.
One of the things that I love most about space exploration is its power to bring us together across belief systems, across nations, across political divides. When we turn our eyes to the worlds and stars beyond, we're reminded that we're all passengers on the same small world. Project Hail Mary captures that spirit beautifully, not just in the unlikely friendship between Ryland Grace and Rocky, but in all of the humans and Iridians who work tirelessly to make these fictional missions possible. We're really fortunate that our survival doesn't currently depend on our ability to explore space, but that is a temporary situation. Whether it's the eventual impact of an asteroid or comet on our world, or the slow but inevitable changes coming to our sun, there will come a day where everything we've learned through exploration and everything we've built through cooperation will matter way more than we imagine. Someday, if life on Earth survives 1 billion years, our survival is going to depend on venturing beyond Earth. Maybe that'll be to the other worlds in our solar system. But an even wilder possibility is that we go to the systems beyond. In Project Hail Mary, that first system is Tau Ceti, but we are so far from being able to make that journey with our current technology. To talk about how difficult that would actually be, we're joined now by Dr. Bruce Betts, the chief scientist of the Planetary Society, for What's Up. Hey, Bruce.
Hi, Sarah.
Hello.
Man, it is really cool to finally get to see Project Hail Mary turned into a film after like reading that book and loving it so much. Honestly, the reason I decided to read that book so immediately after it came out was because of how passionate Mat Kaplan was about it.
Oh, if you did that, you'd read hundreds of books a year.
I know, man. How does he get all that reading done? I love that.
How does he get all that passion?
He just, it's in his bag of tricks. He just, it's bigger on the inside. He just pulls out the passion from the bag.
I know he listens. So, hi, Matt.
The thing is, like, there are so many scenarios in which the Earth could be in trouble and humanity would have to do something crazy in order to fix that situation. I mean, planetary defense is the clearest example here. But in this scenario, in this book, they're literally trying to travel to another star system for the first time in human history. And, they're doing it with some technology we don't have. So we have to kind of suspend our disbelief. But I wanted to take a moment just to kind of express how far it is to actually get to Tau Ceti, that star system that they go to. It is so far away.
How far is it?
Yeah, it's almost like 12 light years away, right? So like 11.91.
It's practically next door.
Practically, I mean, as far as stars are concerned. But that being said, it's like we only just sent humans at one of the fastest speeds ever during the Artemis program. It was like almost 25,000 miles per hour. Although I think that all-time record is actually still held by Apollo 10. But if we wanted to have like the fastest speed possible of any spacecraft that any human has ever sent anywhere, non-crewed, that would be Parker Solar Probe. So if we could go as fast as Parker Solar Probe gets when it's closest to the sun, how long would it take us to get to a place like Tau Ceti? That's my question.
Well, probably like a week or two, you think?
If only.
It's more than that. So if we're going solar probe speed at its maximum relative to the sun of 692,000 kilometers per hour, it would take about 18,575 years.
Roughly. Yikes.
Yeah, that's like, more than 18,000 years. How about we just approximate it like that? So kind of rough to survive that trip, no matter how much you suspend your whatever that doesn't exist now.
Yeah, man, at that point, just,
Yeah, and also you have to, even if you have to slow down once you get there. That's the other trick that's often forgotten, that it's going to be just as hard to slow you down unless you do a flyby, but this wasn't. But you have to slow down just as much as you sped up, basically, roughly.
Yeah. That's going to be really tricky. I feel like if we want to do something like, say, send solar sails or something out to other worlds, like by the time they get there, unless you have some way of slowing them down, they're just going to be booking it so hard you'll have like a couple seconds to get those images before it flies off.
Wait, are you saying that if we flew to another star system with solar sails, it would be hard?
It would be. Still easier than doing something like sending a human to Tau Ceti, but still.
Well, that's true. Very, 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 very hard. That's the technical term.
But really, though, I mean, I would love to see a day in the future when humanity can accomplish something like that. But we're still trying to reach the closest neighboring world with humans again and hopefully land them again on the surface. So we're a long way out from this one. But I love this movie and this book and their message of what it can take when we work together to try to save the world, right? I mean, insert problem here, but like, there are so many things that humanity needs to overcome. And I think when we work in space and we do things that are really hard, it's a great example of how we can overcome those things together. So I hope everyone had as much fun watching this as I did.
Is it time for
Random Space Fact Rewind?
So here's your random space fact. There are 7 moons in our solar system that are bigger than Pluto. For bonus points, recite them to yourself quietly.
Take that, Pluto.
Well, just give a perspective of where it fits in the pecking order of the solar system, and the big moons are big moons compared to that guy.
Yeah, man. Ganymede is like its whole world unto its own. I mean, they're all these really complicated worlds with their own whole thing going on. Like when I was a kid, seeing all the images from Voyager, I figured, these moons would probably be pretty boring compared to the planets. And nope, turns out they're actually in a lot of ways way more exciting. So even though Pluto is small, it is mighty.
Oh, it is mighty, and it is fascinating, and it is weird. So I'm not throwing frozen methane on that. I'm just noting that it's a lot smaller than the moons.
It really is.
All right, everybody, go out there, look up in the night sky, and think about something relaxing.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. And if you're not going to share the show, maybe consider sharing Project Hail Mary the movie with your loved ones. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our online member community. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members. Like Ryland, Grace, and Rocky, none of us can do this alone. It's our collective passion and support of our community that keeps this mission going. You can join us and become part of that community at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Mat Kaplan hosts our monthly Book Club Edition. Make sure to check out his episode with Andy Weir about Project Hail Mary, the book. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.